Hi everyone, Larry Feldman with a lesson on logarithms, or logs as they're more commonly known. Most students dislike, to put it mildly, logarithms, and they can seem a little strange at first, but with a little practice and a good explanation, which I hope to provide, I think you'll find that logarithms are actually fairly easy. And we're going to start with an exponential equation to introduce the topic because logarithms are the inverse of exponential functions. For example, 4 squared equals 16 is an equation involving an exponent. And I'm actually going to break this into different pieces. Let's say the 4 is blue, and this is called the base. The exponent is green, and this is, as I said, the exponent. And then the other side, we're not going to assign a name, but we know it equals 16. So we have three components here: the base, the exponent, and the other side, which is what the base raised to the exponent equals. So since logs are the inverse operation of exponents, we can rewrite this equation in another form. So the way we're going to write that is like this: log base 4 of 16. And let's just look at this for a second. Log base 4 of 16. In words, this means what power do we raise 4 to equal 16? And we know the answer is 2 from above. So this equation really conveys the same information as this equation, but in a different way. So let's look at this again. We start here to convert between log and exponent form. We start at the base, we cross the equal sign, and then we come back. So we start at the base, 4, we go across the equal sign, squared, we write the equal sign, and then we follow this arrow and we write 16. And you see this is the same as this. And this is called converting between exponential and log form. So let's do a few examples. What if I say log base 3 of 9? This is asking, what is the exponent of 3 that I need to raise 3 to equal 9? So we can actually just put a variable here for now, and we can rewrite this equation. And please recall the order. Start at the base, go across the equal sign, 3 to the x equals 9. So with a little thought, we know that x equals 2, right? 3 squared equals 9. Now let's get a little bit more advanced here. What's log base 25 of 5? We can assign this the variable x, and we can say 25 to the x equals 5. Now this one's not quite as easy as the previous examples, but we can figure out the answer a couple ways. One way that a lot of students like is to rewrite the 25 as a power. So the 25 becomes 5 squared. This quantity is raised to the x power, and that equals 5. 5 squared all to the x is 5 to the 2x. This equals 5. And there's an implied 1 here. 5 is 5 to the first. So since the left side equals the right side and the bases are the same, that means the exponents have to be the same. So let's just come over here for now. And we can say that 2x equals 1. That's setting this exponent equal to this exponent. Dividing both sides by 2, we get x equals 1/2. So going back to this equation, we know that 25 to the 1/2 equals 5. And this shouldn't be a surprise because when you raise something to the 1/2 power, that's equivalent to taking the square root. And the square root of 25 is 5. So let me erase this. And let's do a few more examples. What is log base 10 of 10? So again, using words, 10 to what power equals 10? We can put the answer here as a variable since we don't know the answer yet. 10 to the x equals 10. Recall the order when we're converting from log to exponential form. 10 to the x equals 10. And the answer is 1. 10 to the first equals 10. And that actually leads to a very important rule. For any valid base b, log base b of b is 1. This is very important. So thinking about this, if we convert to exponential form, let's come over here, start at the base, b, go across the equal sign, that becomes the exponent, and then we come back. B to the first equals b, which we know is a true statement. Let's do another example. Log base 3 of 1. What does that equal? Let's set it to x. Start at the base. 3 to the x equals 1. This one is a little bit trickier, but with a little thought, we know that x equals 0. 3 to the 0 equals 1, which leads to another rule. For any valid base, b, log base b of 1 equals 0. B to the 0 equals 1. It's always true. Since there's so much to cover with logarithms, I'm going to break up my discussion into 3 videos. So please check out the other 2 videos when you can. In the meantime, please visit my website, www.lfeldman.com, to see links to my math apps, which contain hundreds of examples, tutorials, and solvers. See you next time.